Okay, section 3.7, formulas and functions. So you're going to be learning two skills tonight. The first being, the ability to look at a formula and solve for one of its particular variables. That's something that will come in handy, especially in your science classes. So we'll do a lot of work with that one. And then, as kind of a side note, rewriting an equation in function form. Remember, I told you that we will always come back and talk about functions at some point in every chapter. And so the topic for this chapter is learning how to take something and change it or rewrite it so that it's in function form. We'll come to that one at the end. So let's begin by talking about formulas. It says a formula is an algebraic equation that relates two or more real-life quantities. They usually have more than one variable. And you guys have been working with formulas for some time now. So let's take a look at some that you might be familiar with. This one, you'll remember, is area equals length times width. What about this one? What do you think this one represents? Well, you probably learned this at some point in time. That big P stands for perimeter in this formula, and perimeter, the distance around an object. In this particular object we're talking about appears to be a rectangle. So 2 times the length plus 2 times the width will also give you the perimeter. You can always add up the sides, but this is a short form for the perimeter of a rectangle. This is one that popped up in a previous section, so I hope you remember it. That big I stands for interest. That's simple interest. We'll talk about compound interest later. So simple interest I equals the principal times the rate times the time. How about this one? What do you think that V stands for? This one is volume equals length times width times height. Remember, that tells you how much three-dimensional space is inside a rectangular prism. And then lastly, this one looks a little bit more complex. So what do you think the big C and the big F stand for? Well, this is a temperature conversion formula. This is the Celsius and Fahrenheit formula. So if you know Fahrenheit, you can convert it into Celsius. This is Celsius equals 5/9 times the quantity, Fahrenheit minus 32. Okay. One thing I want you to notice is that in all of these formulas, they are solved for one of the particular variables. In the first one, it's solved for area. Although if we wanted to, we could solve it for length and we could solve it for width. We could choose one of the other variables to solve it. This one just happens to be solved for area already. In this one, it's solved for perimeter. This one is solved for interest. This one is solved for volume, and this one is solved for Celsius. So typically we're going to solve a formula for the quantity we want to know. Okay, going back to the first one, apparently whoever wrote this one wanted to know area. If they wanted to know the width, they would write it another way. Or if they wanted to know the length, they would write it another way. And that's actually what we'll be practicing, is how to maybe change these around so we can solve for other variables if we want to. Okay, so let's look at that area equals length times width formula. It says we often need to manipulate formulas to get the information we need. In the above formula for the area of a rectangle, we might need to solve for W. So we divide both sides by L. Okay, now that is an option. You could divide both sides by L and isolate the W. So whatever you want to solve for, in this case, if you want to solve for the W, treat it like it's the only variable and get it by itself. Okay, so let's go through the process on this one. And if you want to, you can go ahead and write this one down on your paper. So area equals length times width. Okay, and if we want to solve for W, since the W and the L are joined by multiplication, we would divide both sides by L. And L over L would cancel out. So notice how the W is by itself right now. So width is equal to the area, capital A, over the length. It's the exact same formula. It's just been rewritten so that it's solved for W. And the majority of your assignment is going to be manipulating formulas like this. All right, let's take a look at a more complicated example. Go back to that Celsius Fahrenheit one. Okay, now we saw that this is, the formula. If you happen to know Fahrenheit, you can convert it into Celsius. So a lot of the world uses the Celsius scale. If you happen to know the Fahrenheit, you could be able to convert it to the Celsius, and that's cool. Now, if you go traveling, probably not going to help you if you're used to the Fahrenheit scale. You're going to be given Celsius. You're going to want to know what the Fahrenheit is, so it makes a little bit more sense to you. So what we're going to do is we're going to change this equation around so that we solve it for Fahrenheit. Fahrenheit is going to be isolated, and the Celsius will be part of the formula, something for us to plug in, kind of like an input. Okay, so let's see if we can get the F by itself. All right, what do you think would be the first thing you would do? It says C equals 5/9 times the quantity F minus 32. And imagine that F is like an X, right? You want to get it by itself. Well, we have a fractional coefficient outside of a quantity, okay? We want to get rid of that 5/9 first. So how would you get rid of the 5/9? And you'll remember that you would multiply both sides by the reciprocal. And what is that reciprocal? It's 9/5. So your first step would look something like this. Multiply the right-hand side by 9/5 and multiply the left-hand side by 9/5. What is that going to accomplish? Well, 5/9 times 9/5 is going to completely cancel out the fractional coefficient in front of the F minus 32. So these guys are going to totally cancel away. And that's where it just leaves F minus 32 on the right-hand side. And you'll notice that because it's just F minus 32 right now, there's no need for parentheses anymore once that multiplier on the outside goes away. So we're left with 9/5 C equals F minus 32. What would be your next step? Well, you would add 32 to both sides. And it's kind of weird because over here, these aren't really like terms that you could combine. 9/5 C is kind of like a couple, and the plus 32 is sort of like a loner, and they don't really go together. I can still write them like that. These guys are going to cancel out, and you'll notice that your F is all by itself now. So Fahrenheit F equals 9/5 C plus 32. I can go ahead and guarantee you right now this Fahrenheit Celsius conversion, you're going to get one of the versions of this on a quiz or a test. So you want to practice going back and forth from Fahrenheit to Celsius and from Celsius to Fahrenheit to make sure that you're comfortable in doing this. And hopefully you just did this one on your paper along with me. Okay, so that's the first skill, being able to isolate different variables inside formulas. Let's take a look at the second skill. Second skill is function form. Okay, what do we mean when we say function form? So a two-variable equation is written in function form if one of its variables is isolated on one side of the equation. So something is written in function form if we take any one of the variables and just get it by itself. Okay? The isolated variable is the output and is a function of the input. And here's where you need to pay very close attention to the language. Okay? Our example is the perimeter of a square. Okay, that's P equals 4 times S. Okay, perimeter equals 4 times the side length. In a square, all of the sides are the same. You could add them up, side plus side plus side plus side, or we just say 4 times the side length. So P equals 4S. Now, notice, the language we're going to use here is we'd say that this formula describes the perimeter P, okay, so P of a square as a function of its side length S. So P as a function of S. And that order is very important. When we say P is a function of S, we're saying that the perimeter is the variable that is isolated. The P is going to be by itself, and the S is going to be with the other parts of the formula. Okay? If they said s as a function of p, you'd have to get the s by itself. And the reason I'm stopping to explain this is because you're going to have to know by the language which variable to put all by itself. Okay? All right, so once again, over here in the formula, since the p is by itself already, we would say that this is p as a function of s. All right, let's see where we're going with this. All right, rewrite the equation 2x minus y equals 9 so that y is a function of x. Notice they don't come right out and tell you which variable to put by itself. So do you think they want you to put the y by itself or put the x by itself? Okay, well if they say y as a function of x, it's the first one they mention. You're going to have to get the y all by itself. So what I want you to do right now is I want you to write this down on your paper, 2x minus y equals 9, and I want to see if you're able to isolate that y and get that y by itself so that we put this in function form. So we'll either say y as a function of x or put it in function form, solve for y. Okay? Go ahead and try that on your own right now and hit pause. We'll come back to reconvene and go over the correct answer. All right, let's see how we did. So on your paper, hopefully you went and copied this down, 2x minus y equals 9. Your first step should be to get the y by itself. So we are actually going to subtract 2x on both sides. You know, you're treating the y as kind of like the only variable, and even though it's not a loaner, it's kind of like the 2x is a loaner. You're going to get rid of it first. So these cancel out, and you're left with negative y equals, now you can write this as 9 minus 2x, and that would be totally fine. But you're going to want to learn to put that x stuff up front, or the variable stuff up front. So I'm going to write this as negative 2x, and that's a positive 9 up here, right? Positive 9. So plus 9. No, 9 minus 2x is the same thing, so that's fine if you have that. Okay? So negative y equals negative 2x plus 9. We want to know what positive y is, though. So how do I get rid of that negative sign by the y? Hopefully you remember you're going to divide both sides by what? Well, you're going to divide both sides by negative 1. So left-hand side divided by negative 1. Entire right-hand side divided by negative 1. Remember, when you're multiplying or dividing, it affects the whole entire side. So a negative y divided by a negative 1 is a positive y. Over here, you're going to have that heart method thing we practiced earlier. So negative 2x divided by negative 1 is going to be positive 2x. And positive 9 divided by negative 1 is going to be negative 9. So you should come up with y equals 2x minus 9. Okay? Let's go ahead and do another one just really quickly while we're on this. Go ahead and copy this one down on your paper. 4x plus 2y equals 20. And I want you to do the same thing. I want you to rewrite this so that y is a function of x. Okay, aka put it in function form and solve for y. Go ahead and hit pause and do that on your own right now, and then we'll reconvene to go over the right answer. Shouldn't take you too long. You can use the other one as a model. All right, let's see how you did. First step, taking away 4x from both sides. You just want to get really fluid with this. On the left-hand side, you'll be left with 2y. And on the right-hand side, you're going to have negative 4x plus 20. Now what do? Well, we got to get rid of that 2 on the left-hand side. So it's glued to the y by multiplication. We're going to divide both sides by 2. Remember, that impacts the whole entire side. These cancel out, and you'll be left with y equals And what does this become? Negative 4x divided by 2 is negative 2x. And this becomes plus 10. Why are we learning this right now? Well, it's really important because in Chapter 4 we're going to get into graphing. And you guys did some graphing in middle school. Both of these guys, both of these equations right here, both of these functions, look like things that you would graph on the coordinate plane. So we like to rewrite them in this form. It makes them a little bit easier to graph sometimes. So it's important to be able to isolate that y and come up with the right equation so that you come up with the right graph. And so this skill is going to carry over. It's going to spill over into Chapter 4. All right, let's move ahead. So you have a couple problems already down on your paper, but here come your official examples. So same thing we've just been practicing. These answers won't look as nice, but they'll be correct answers nonetheless. So rewrite each equation so that y is a function of x. I could have asked you, so that x is a function of y, and you might have to do that on the assignment. But all of these have you solving for y. Okay, so go ahead and practice this on numbers 1 and 2. I think you'll get some fractional answers, and that's fine. And then we can come back and reconvene and go over what is correct. So go ahead and hit pause now. Okay, you'll notice that these are set up a little bit differently than the ones we did in examples. Take a look at number 1. We have the negative 5y plus 10 on the right side. So to get the y by itself, first steps here are taking out the 10. So, we're going to subtract 10 on both sides. Notice that these guys over here, they're not like terms, so they cannot be combined. So they're going to stay as such. 9x minus 10 equals negative 5y. That would be step 1. Step 2, we got to get rid of that negative 5. So we're going to divide both sides by negative 5. Okay, question is, what does this all become? All right, well, we're going to be left with y by itself on the right-hand side. Over here, we're going to do a heart method. So 9x divided by negative 5. And it's totally okay if you wrote this, 9x over negative 5. It's not wrong. It's totally right. But I'm going to ask you to start writing it a different way because this is going to help you in Chapter 4. Another way of writing this is to consider the 9 divided by negative 5 as a fraction. So we're going to write this as negative 9/5 times x. And it really means the same thing as putting the x in the numerator, or you can just have it as a fractional coefficient, negative 9/5 x. Okay? Over here, negative 10 divided by negative 5, that's going to be a negative divided by negative is a positive 2. So plus 2. And then if you want to get, if you want to reverse this so that y is on the left, if that makes you feel better, cool, you can do that. Negative 9/5 x plus 2. Why was I making such a big deal about that coefficient stuff? Well, when you write it in this form with the negative 9/5 looking like this, you'll remember from middle school that this guy right here is your slope of your line, and this guy right here is your y-intercept. You probably did slope-intercept form last year. This actually is slope-intercept form. We can also call it function form, where y is a function of x. So you want to practice writing that fraction like so. And see, I think over here we might get another opportunity to do it. Let's take a look at number 2. So we want to get that y by itself. First steps, we're going to add 7x to both sides. Notice that 20 and 7x are not like terms, right? So they can't really be combined. Remember, to be like terms, you have to have the same variable raised to the same power. One of these guys has an x and the other one does not, so they're not alike. So we're just going to write them as 7x plus 20. And remember, if you have 20 plus 7x, that's also correct here. All right, next step, getting rid of that 6, we're going to divide by 6. So divide both sides by 6. And you're left with y equals. All right, let's see if you can do the fraction right this time. 7x over 6, we can rewrite that as 7/6 x. and then plus 20 over 6. Now that's something that needs to be reduced. Notice that the 7 6 can't really be reduced. And you don't need to change it to 1 and 1/6. That whole lie about changing things to a mixed number that you were sold in 5th grade, it's not really true in algebra. You know, improper fractions are totally fine. They're better for slopes. So this guy right here can stay as 7 over 6. But 20 over 6, yeah, that can be reduced. Both of those numbers can be divided by 2. So that's going to be positive 10/3. And that would be your function form. Y equals 7/6 x plus 10 over 3. And hopefully you got both of those right. All right, let's go back to the beginning of the section where we talked about isolating variables. Okay, so I'm going to give you 4 of these to practice on first, and then you're going to be hit with another 4. We'll do the first one together. Okay, make sure you get off to a good start. So on number 1, it says solve for W. And this is the formula for the volume of a rectangular prism. Okay, so if I want to get that W by itself, what would I need to do? What do you think we need to do? Well, it's glued by multiplication to both the L and the H. So you're going to divide by L and H at the same time. And technically that's L times H down there, but you can totally do that. You want to get W by itself, divide by L and H at the same time. Just whatever you do to the right, you're going to have to do to the left as well. Notice that the L's are going to cancel, the H's are going to cancel, and you'll be left with W all by itself. Okay, so width would be the volume, capital V, over the length times the height. And that would be fine. If you want to write the W on the left-hand side, that's cool too. All right, so go ahead and try numbers 2, 3, and 4. Just pay attention what you're solving for. And you'll notice that some of these are easy and some of these might be a little bit more difficult and challenging. That's okay. But go ahead and try them on your own. Hit pause now, and then we'll reconvene to go over answers. All right, let's take a look at number 2. It says solve for R. So what are we going to do to both sides? We're going to divide by T. Okay, this is distance equals rate times time. I believe we talked about that one already. So if we wanted to know the rate, if we wanted to know the speed, we would divide both sides by T, and we get R equals D distance divided by time. And that's, it's funny if you think about it. Distance divided by time, it's why we say miles divided by hours. That's distance over time. That's our rate. That's our speed. Okay, so hopefully you got that one right. Number 3, hopefully you recognize this one. Capital C equals pi times D. That's circumference equals pi times diameter. Now you want to get diameter by itself, so what did you do to both sides? You're going to divide by pi. This one will come in handy in your geometry class. But you use a lot of algebra while you're doing geometry. Notice your pi's cancel, and you get distance, diameter, rather. Diameter equals circumference divided by pi. Okay, diameter equals circumference divided by pi. Very good. Now number 4 was, tricky. It says area equals pi times radius squared. And they want you to get R by itself. And don't feel bad if you get this one wrong, but just kind of pay attention to the logic of this. Kind of like circumference equals pi times diameter, we're going to divide by pi first to get the R squared by itself. Notice the pi's canceled there. And we have R squared equals capital A area over pi. Okay, so how do we get that R by itself? I don't think we've seen this yet. Okay, if you got R squared, how do we unsquare it? What's the inverse operation for squaring? Well, the inverse operation is taking the square root of both sides. So here's what that would look like. I'm just going to recopy this really quickly. To get rid of that squared, you would take the square root of the left side and the square root of the right side. And a square root and a squared will cancel each other out. So the radius is equal to the square root of the area divided by pi. Kind of an advanced formula, but hopefully you understand the process. First we divided by pi, and then we took the square root of both sides. Okay? All right, let's try some more. This is a mix. Some of these will be easy, some of these will be medium. Maybe one of them might be a little bit more challenging. So go ahead and isolate the given variable, 5, 6, and 7, and 8, solving for h, l, b sub 2, and c respectively. Give it your best shot. Go ahead and hit pause now, and then we'll reconvene to go over answers. Okay, let's see how we did. Number 5. And there are different routes for doing this, so you might not do this the exact same way. But I'm going to begin by getting rid of the 1/2. And it's kind of crammed in here, but to get rid of 1/2, remember you're going to multiply by 2 over 1, or just multiply by 2. So I'd probably multiply by 2, multiply by 2, something like that. And notice that 2 times 1/2 is going to cancel out. It's going to make a 1. And you're going to be left with 2 times the area equals base times height. What is that formula? Area equals 1/2 base times height. Well, that's the formula for the area of a triangle. Hopefully you remember that. All right, we're trying to get h by itself. So now we're going to divide away the b. Notice the b's cancel, and the h, the height, equals 2 times the area divided by the base. So hopefully you got that. All right, number 6, back to that formula for area of a rectangle again. This time we're solving for L. So we're going to divide both sides by W. Pretty easy stuff at this point. Okay, so this is probably making a lot more sense now. L equals capital A area over width. All right, number 7. Maybe you recognize this guy. This is the formula for the area of a what? And maybe you've seen it before. It's area of a trapezoid. Okay, so remember, trapezoid is, you know, that figure. Maybe it sometimes looks like this, and it has a height to it. Oh, that's pretty nasty. Let me try that again. It's got a height, which usually is given by a dotted line. Okay, and then it also has 2 bases, and those bases are the parallel sides. And so we sometimes label these base 1 and base 2. Okay, and often they are, well, they are different lengths. Okay, so that's sort of the anatomy of the trapezoid. Okay, with the height right there. So let's see, we want to solve for b sub 2. Now notice b sub 1 and b sub 2, they're in the numerator. It's kind of like they're protected by parentheses. We're not really going to be able to get at them until the very end. So we want to start by either handling the divided by 2 or handling the times the height. And you really could start with either of those. I'm going to start with the divided by 2. I'm going to multiply both sides times 2 over 1. Kind of like we did with the triangle formula. Those 2's will cancel out, and I'll be left with 2a equals base sub 1 plus base sub 2. Still protected in the numerator, even though we don't have a fraction anymore. We need to know it's both of those things added first and then multiplied by the h. Now I'm going to get rid of the h by dividing both sides by h, because that h is glued to the quantity by multiplication. H over h cancels out, and we're left with 2 times the area over h equals base sub 1 plus base sub 2. All right, we want to get b2 by itself, so we're going to subtract away b sub 1. And notice those are not like terms. So really all I'm going to do is kind of rewrite this nicely. Base sub 2 equals 2a over h minus b sub 1. And that's definitely a problem you want to study. Good chance you might see that on an upcoming quiz or test. All right, last one. E equals mc squared. It's one of those famous equations from Einstein. Energy equals mass times the square of the speed of light. That's what the little c in this one stands for. And we're trying to get that c by itself. So kind of like the area equals pi r squared, we're going to begin by dividing away the m. Okay, so we have energy over mass equals the speed of light squared. And then hopefully you remember what we do to both sides. Okay, this is where, to get rid of that squared, we're going to take the square root of both sides. So on the left, we're going to take the square root of E over M. And on the right, we're going to take the square root of C squared. And square root and squared cancel out. So now you have C by itself. So C equals the square root of E over M. Okay, I know tonight was a little bit longer, but this is a really, really important skill, especially if you want to be successful in your science career here at Brophy and beyond. So hopefully you did well on these. You didn't need to get them all right, but you did need to practice all of them to be ready for next class. All right, good job.